In this problem, we've been asked to determine, when given a grammar and a string, if that string shows that this grammar is ambiguous. So how are we going to do that? The key here is going to be in writing out derivations of the string under that grammar. Let me show you an example. So here I've written out a grammar. For the sake of writing out the derivations, I'm going to label each rewrite rule with a number, just an identifier. So I can refer to this rule as rule 1. Let's say my given string is the string A and B. So what are some ways I can derive AB given this grammar? Starting from S, I can take rule, let's do 0. That takes me to P. From P, I can go to AT using rule 2. From AT, I just need to get B. Unfortunately, using rule 5, T goes to B. So there's one way to derive the string AB using this grammar. And later on, when I do solve this problem, I'm going to refer to this derivation in the form of a list, where I took rules 0, 2, and 5 to get AB. Now, to determine whether or not the grammar is ambiguous with regard to this string, I need to try and find another derivation. So if I take rule 1 instead of rule 0 starting from S, that gives me A and Q. From AQ, I can take rule 4. Rule 4 goes to B, giving me AB. So the derivation is 1, 4. So I found two derivations. These are two very different derivations for the string AB under this grammar, starting from S. So that's kind of a good example, but how does that help us solve the problem? So just like an earlier problem in this homework assignment, we get to make an important assumption. So the important assumption I'm making is that whatever grammars we feed into our function, they have a finite number of derivations. This actually means that there's a finite number of strings in the grammars. So they may not be all that interesting, but nonetheless, determining whether or not they're ambiguous is a very cool problem. So what does that allow us to do? Well, it grants us the ability to get a very simple solution for detecting whether or not the grammar is ambiguous. And what we're going to do is simply exhaustively enumerate all of the derivations for that grammar. And the way we're going to do that is take the expand function that we wrote at the end of the lecture unit. Instead of enumerating just the strings, we're going to enumerate strings along with their derivation. Once we've enumerated all of the derivations, we can check more than one derivation for that string. If we have found one, then the grammar is ambiguous. Otherwise, it's not. So if you're like me, you're eager to get right to the code. Let's do that. So as the hint described, the first thing we're going to do is write our expand function. And this is going to be taken almost right out of the lecture. If you don't remember or haven't seen this syntax before, this says I'm going to take the first and second values out of tokens and derivation and put them in the tuple tokens comma derivation. Here I have two loops that are going to enumerate each token in tokens and each rule in the grammar. I'm going to access them as I want given their position or index. So this gives me the rule out of the grammar. This says if the current token applies to this rule, it's on the left-hand side of this rule, then I'm going to do the following. I'm going to yield, as part of this generator function, a tuple where the first value in the tuple is the current state of the string. I'm going to make one substitution. That's what I'm doing here. I'm including everything to the left of the current token, making the one substitution, and then I'm including everything to the right of the token. And then I'm updating the derivation with the rule I used. So what does that look like? If I go back to the example I had here, let's say I pass in S, I am going to go through this list and see every rule that applies to S. Well, rule 0 and rule 1 both apply to S. So I'm going to yield two things. First one is going to be P, because I'm substituting S for P, and then I'm going to return the derivation, which is using just rule 0. That's going to be the first thing I yield. The second thing I yield is going to be the substitution for the second rule, or rule 1. And so what I'm going to do in the body of is ambiguous, now that I have the expand, is I'm going to go back around and expand this expression even more. So when I expand this expression, I'm going to get two things. The first one is going to be using rule 2 to get AT, and the next one is going to be using rule 3 to just get C. And so as you can see, I'm starting to build up all these derivations. And so what I'm going to do in is ambiguous is I'm going to keep building up all these derivations until I can't expand anymore. And then I'm going to look at all the derivations that yield the string I was originally looking for. All the derivations, once fully expanded, yield AB, and then check to see if I got there the same way. If I got there in two different ways, then the grammar is ambiguous under the string I was looking for. Otherwise, it's not. So let's go write that function. So I've declared my function. I've taken a grammar, a starting location, a starting symbol, and the utterance that I'm looking for. Enumerated is going to be all the possible strings in the grammar I've built up so far. And since I'm just going to start with start, the first value in the tuple is just going to be the string start, or just the symbol start. It's a one symbol string, and an empty derivation since I haven't done anything yet. So what do I have here? I'm going to take my enumerated list, try to enumerate it more, try to expand it using the expand function. And if it changes, then I'm making progress. I'm finding new strings, I'm expanding the derivations, and so I should keep going until I've gone through all the finite number of derivations. If this hasn't been updated, I haven't done anything new, the expand function didn't find anything new, and so I'm just going to break because I'm done. I found all the derivations I was looking for. So what I'm doing here is I'm going through each entry in my enumerated list. I'm going to try expanding that entry. If I found something new, then I'm going to add it to my new enumerated list. Otherwise, I'm not going to do anything. So what this is going to do is going to update new enumerated for every new thing expand finds. And so once I've done all that, I'm going to count how many derivations I found for my utterance. And if I found more than one, then I've shown the grammar to be ambiguous. And I'm doing that by doing a list comprehension that essentially filters out everything that's not related to the utterance, and then taking the length of that list. If it's greater than 1, then I found 2 derivations. Otherwise, I haven't. So that's how you solve this problem.